Okay, right here I have the Ainslie circuit running. This one single battery right here is at 12.61 volts right now, and the negative of the battery I have going to one end of this current sensing resistor, and the other end of this current sensing resistor, the yellow is going to the source of the MOSFET, and this green wire is going to the negative rail of the timer. So measuring this one shunt, I'm getting the power draw from both the load and the timer. The positive, I got two positive wires on this battery. One positive is going to the top of the load, and then bottom of the load to the drain of the MOSFET. The other positive wire is going through this pot meter here, and then yellow wire is coming into the diode on the positive rail. So anyway, both are running on this one battery. The point to this video is I just want to show these little nonlinear zones depending on how it's tuned, and I don't know how significant they are, except that I've played in those little regions quite a bit, and I just want people to at least be aware that they do exist so that you can make up your own mind what it means for you. But in those little zones you can see that you can either get more or less compared to the other regions that are pretty linear. And so anyway, right now this is the off time pot, and I have it turned all the way to the right, and for this setup that means there's maximum off time. And so off time is maximum. Right now I have these oscillations right here. You see these oscillation bursts, and if I increase the off time, all I'm going to do is bring it like this, which is decreasing off time. And as I decrease it, you can see that's going into full-blown oscillation without the brakes. But anyway, I'll turn this all the way back to maximum off time. Okay, and I have this across the shunt for the power measurement. But I have this directly across the load. The Tektronix yellow trace is exactly grounded to the negative of the inductive resistor load, and the probe is going to the top of the inductive resistor load. And this is just to show the waveform of how it grows and shrinks depending on the setting, and that it's not always linear. And so anyway, for example, this is with maximum off time, and you can see that I got these oscillation bursts here. Okay, but all I want to show is what I'm going to do now is I'm going to decrease, a little glare there. Okay, what I'm going to do is decrease off time. Okay, I'm decreasing off time. I'm simply going to rotate this counterclockwise on the off time to decrease off time. And as I'm decreasing, everything is pretty linear right now. You can see that the amplitude is growing. Okay, now right at this point, this is linear, it's still linear, and you see it jumps to that point right there. Still linear because decreasing, everything is still moving in the same direction. But as soon as I go past that point, you can see that it's shrinking, and I'm moving the dial in the same direction. Okay, so you can see that it's not linear there. Okay, here's linear, it's linear, it's linear, and then it's not linear right there. It starts to shrink back down. But if you notice, here's back to this linear region, going linear, comes down there, and then you can see I'm turning it in the same direction, and it starts to shrink down. Okay, so that little area right there, and if I keep going, it'll bring everything to floating above positive, or above ground. But anyway, this is increasing off time, increasing. See the amplitude shrunk right there? Okay, amplitude's growing, and then the amplitude shrank. So going in that direction, it's not linear. Okay, and I want to find a few more examples where this might be a little bit more apparent. Now here's the on time. I'm just changing the on time, and right now the on time is, okay, this is minimum on time, and this goes increase on time. So I'm going to start at the minimum amount of on time, okay, which is basically shutting off the power and it can't even run. So I'm going to increase the on time right here, okay. Okay, that's increasing on time. I'm just going to increase it, hops up to that point. Now I'm going to keep increasing the on time. Now look, it's shrinking back down. Okay, then it's growing again. And so if you notice right there, you know, that's where the amplitude is the lowest. And I'll increase the on time. And I'm keep increasing in the same direction. And if I just keep increasing, it's going to float everything above ground there. Okay, so I'm totally above ground. Okay, now I'm going to bring it back down, and I'm decreasing on time. And just watch that goes right there, then it starts to shrink back down. Okay, so in those little zones right there, you can kind of play with. You can either leave it where you want the long points, or where it's shorter, like right there. And if you just divide the RMS by the DC, you'll see what kind of spreads you're getting, and you can compare. And again, I'm not saying that what type of significance this is, just that you should be aware that there are these little zones where the amplitude and the amount of current flowing does not coincide, which means it's similar to those negative resistance zones in some transistors, like the MJL21194, the 2N2222, and a few others. And so anyway, this is decreasing on time, decreasing, decreasing, and we're just back down. And you can find those zones with pretty much any dial. Okay, now what I'm going to do is I'm going to start increasing the on time. Okay, I'm increasing it. Now we actually are getting some power to it. Okay, this is increasing on time. Okay, increasing. And as I'm increasing the on time, you're going to see that the amplitude just shrank. Okay, so let's see. Let me get this on a different scale so you can see it better. Okay, so I'm going to decrease on time. Okay, that's very minimal on time. I'm increasing the on time. Let's see. Okay, right here we're into a pretty solid waveform here. Okay, I'm going to increase the on time, and you can see that it shrank. Okay, I'm going to decrease on time more. Okay, now I'm going to start increasing on time. This is more on, more on, more on, and then you see it starts to shrink, and then it starts to grow again. Okay, now it's higher amplitude. I'm increasing on time, and it's shrinking down. I'm increasing on time, and the amplitude is growing again. I'm increasing on time. Okay, now we're out of that range there.